Hello everyone, welcome back to Chemistry 24 into 7 series. In this series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So today we are going to see the heck related problem. So this is the question from CSIR 2015. As per this question, this substrate react with this alkene under palladium catalysis which produce a product. That product react with this alkene under palladium catalysis that produce a product. So here there are four options are given. Let's solve together which one is the correct option for this question. So this is the reaction condition for Heck cross-coupling reaction. So we have already discussed about Heck cross-coupling reaction and their catalytic cycle, magnetic detail and various examples. If anyone missed that video, you can find a link in the description box below. So now comes to the our problem. So the first step of the reaction would be a generation of active palladium catalysis. So in this reaction, active catalysis is palladium zero catalysis. So therefore, palladium acetate and triphenyl phosphine that react together that generate palladium zero active catalysis. So now this palladium zero catalysis readily undergo oxidative addition with our substrate. So here you closely look, our substrate contains two reactive sides. So one is here, so this carbon iodide bond, and another one is here, this carbon bromine bond. So when you compare these two sides, this side is more reactive which readily undergo oxidative addition with this palladium complex to produce this corresponding palladium complex intermediate. So now this intermediate react with alkene by carbopalladation to produce this corresponding intermediate. So here you should note that so this palladium part as well as indole part both insert into this alkene by synphation. So resulting that produce this corresponding complex. So the next step of the reaction would be a syn beta hydride elimination. So for this, particularly this position, we need hydrogen atom. So therefore, when you rotate this carbon-carbon bond, which generate these two intermediate forms, so now you see this intermediate form. So now this ester group as well as indole part both are present at top phase. So therefore here there will be a heavy steric class in between this ester as well as indole group. So in case of this structure B, so now you see this NH acetyl group and indole group both are present at bottom phase. So here also there will be a heavy steric interaction between NH acetyl as well as indole part. So now you compare these two structure. So this is most preferred conformational form. Therefore, so this one readily undergo syn beta hydride elimination, which produce this corresponding alkene product. So now you see indole part as well as NH acetyl group both are present cis to each other. So why this form is most preferred form? Since now you compare the steric between now you compare the steric nature between ester as well as NH acetyl group. So NH acetyl group somewhat less steric when compared to the ester group. Along with the generation of this corresponding palladium complex, this palladium complex readily undergo reductive elimination to generate palladium zero active catalyst along with this triethylamine hydrogen iodide adduct as a byproduct. So now this intermediate react with this alkene in next step one more Heck reaction. So as per our Heck reaction, here also the first step of the reaction would be a generation of palladium zero active catalyst. So after that, now this intermediate compound react with this palladium complex which readily undergo oxidative addition to produce this corresponding palladium complex. Now this palladium complex react with this alkene by carbopalladation reaction which produce this corresponding complex. So here you should note that this palladium part as well as this indole part both insert into this alkene by synphation. So our convenient, this indole part we can name as R. So the next step of the reaction would be a syn beta hydride elimination. For that we need hydrogen atom, particularly this position. So for that you just rotate this carbon-carbon bond that makes these two conformational form. Now you compare the steric between these two conformational form. The first one, so now you see this bulky group as well as this indole group both are present at top phase. So definitely there will be a heavy steric class between this indole as well as this group. In case of this conformational form B, so here there will be a little steric class between this indole part as well as this group. So therefore, this particular conformational form B readily undergo syn beta hydride elimination to produce this corresponding alkene product. So now you see, so this group as well as indole part both are present trans to each other. So apart from that, so this reaction produce this palladium complex as an intermediate which then readily undergo reductive elimination to produce palladium zero complex as well as this triethylamine hydrogen iodide adduct as a byproduct. So let's moving to the our question. So as per our discussion, among the four answer, the correct option for this question is option 4. That's it for today's problem. I hope this video has helped you to understand this heck cross coupling related problem. If you enjoyed this video, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.